All right, so sometimes we don't know the y-intercept of a line. Sometimes we're just given the slope and a point or 2 points on a line. So that's where this equation becomes very handy to know. This is point slope form. And what it is, so it still has a y and an x just like we're used to. The m still stands for the slope. And then these two, the y1 and the x1, those are points on the line. So this is very handy for when we do problems like this, where they just give you the slope and a point. We can plug it into this equation and then manipulate it to be in y equals mx plus b form. Let's give it a try. A line has a slope of -2 and passes through the point -2, 0. All right, so I'm going to plug it in. Y equals, oh, by the way, hold on. Perhaps before we do that, we should label, this is the slope. This is going to be in place of m. -2 is x1. 0 is y1. Okay? So now, plugging in y minus y1, so y minus 0 equals the slope, -2, times x minus this one, the -2, because that goes in place of x1. All right, now we just need to simplify. Now y minus 0, of course, is just y. Here I'm going to make that into a plus, right? And now I'm going to use the distributive property. So -2 times x is -2x. -2 times 2 is -4. And that's it. That's our answer. Let's try it again, but this time where we're just given 2 points on the line. So this time, the thing that's different is I don't know the slope, but we know how to find the slope. So slope is y2 minus y1 over x2 minus x1, of course. So the 4 is going to be x1, the 9 is going to be y1, the -2 is going to be x2, and the 0 is going to be x1. So now let's plug it in. The slope will be, that's a y. That does not, sorry, that doesn't, let's fix that. That should be y2. There we go. All right, so we have y2 minus y1 over x2 minus x1. So that gives me -9 over -6. And of course, we are good mathematicians who always simplify our fractions. I notice there's a negative in the top and a negative in the bottom. That means it's going to be positive. And I'm going to simplify this to 3 over 2. Now I know the slope, and I can pick a point. Whichever point, it really doesn't matter. You actually get the same answer either way. I will prove it to you. We'll do it twice. All right, so if I plug in, remember your point slope form? Point slope form, it's right up here. Y minus y1 equals slope times x minus x1. Okay, so y minus y1 equals slope times x minus x1. Let's see what we get. So I have y minus 9 equals, here I'm going to do the distributive property. This is going to be 3/2 x minus, now 3/2 times -4. Well, we know it's going to be negative. 3 times 4 is 12. 12 divided by 2 is 6. And of course, the last thing I'm going to do, add 9 to both sides, and we get y equals 3/2 x plus 3. Now, just for fun, I'm going to prove to you that we get the same answer if we were to plug in the second point. So this time I'm going to plug in this point instead. Let's see what happens. So if I plugged in this point, I would do y minus y1 equals the slope times x minus x1. So I'll get y minus 0 is just y. Then I'll have 3/2 x. Now this is going to become a plus, right? So that's positive. So this is going to be plus 3/2 times 2. Well, 3 times 2 is 6. 6 divided by 2 is 3. And that's my answer. See that? You get the same answer no matter which point you plug in. Isn't that cool? So on this one, the main thing is we had to find the slope first, and then it doesn't matter which one you do, either point, you'll still get the same answer. You do not need to do it twice. You could do it just once. I just wanted to show you that it works either way. All right, cool. All right, and these are your try problems.